Have you ever opened a folder that had another folder that had another folder? That's recursion. So in programming terms, recursion is simply a function calling itself to solve a smaller and simpler version of the same problem. Okay, so real life analogies of recursion would be a Russian toy door. Okay, so it's basically a big door holding a smaller door, holding a smaller door, holding a smaller door until it gets to the smallest door. Okay, so we have two parts of recursion. We have the base case and the recursive case. Base case is the part of the function that brings the function to an end. So it is very necessary to have the base case. While the recursive case, as the name suggests, is the part where the function is calling itself, and they both have to work hand in hand in order to achieve what you want to do. So in this video, we'll be looking at multiple examples and we'll be using JavaScript. So along the way, I would also share the code snippet for Python and Java. Let's get started. So in my VS Code here, I'll create a new file. I'll call it examples.js. So I'll basically go through 5 examples. So it's increasing difficulty. So let's start with example 1. We say let's do the factorial function. So for those of us not familiar with the factorial function in maths, it's basically, if I say 5 factorial, basically means 5 times 4 times 3 times 2 times 1. So the factorial of a number is the number multiplied by all the previous numbers till 1, until it gets to 1. Okay, so let's write the implementation for that. So we say function, let's call it factorial. Right, so my factorial number will take an argument n. So whatever number I want to find the factorial of, n represents that. Okay, so now let me start with the base case, the part of the function that makes the function stop. So I'll say if n equals 1. I'm using 1 here because 1 is the smallest part of this factorial function, because as I said, 5 times 4 times 3 times 2 times 1. So 1 is the smallest possible version, or the smallest or the easiest number that this function should be able to take. Right, so if n equals 1, just return 1. Okay, so return statement will obviously make the function stop. Right, so I can say this is the base case. Right, now our recursive case. So I can use an else statement here, but if it doesn't get caught in this if statement, whatever is left will get executed. So I'll just say return. Well, I want my return statement to work regardless, so I'll just say return n times factorial again. So I'm calling the function inside. So I'm calling the function inside. So I'm calling the function again, but now I'll pass minus. So n times factorial. So I'm calling the function again, but now I'm going to pass n minus 1. So what this basically does is to check if the number is 1, just return 1. If not, what? Return the number times the factorial of the number before it. Right? So let's play this out. So if I say factorial of 5, right? Factorial of 5 will do what? 5 comes here. So 5 is basically representing, or n represents 5 now. Is 5 equals 1? No. So it comes here. 5 times factorial. So that would be 5 times, let's say f, right? Factorial of 5 minus 1, which becomes 4. So now it performs, so this is like me calling the function. So it executes that. So it executes what? Factorial of 4. So now what is factorial of 4? Factorial of 4 will be, is n equals to 1? Is 4 is equals to 1? No. So it returns what? 4 factor, let's just say let's say f of 4 minus 1, 3. It keeps on going. F of 3 equals is not equals to 1, so it's 3 times what? F of 2. Alright? F of 2 is what? F of 2 is 2 times f of 1, and f of 1 would be 1. So when it gets to factorial of 1, this if statement finally can be executed. So 1 equals 1, it will now return 1. So it means factorial of 1 returns the value of 1. So here, instead of doing 2 times factorial of 1, it does 2 times 1, since factorial of 1 returns 1. So it means factorial of 2 equals 2. So instead of 3 times factorial of 2, it becomes 3 times 2, which is 6. So instead of factorial of 3 here, it becomes 4 times 6, which is 24. So factorial of 4 is 24. And finally, instead of 5 times 4 factorial, it will be 5 times what? 24, which would be 120. So it means the factorial of 5 should be 120. So since I'm using JavaScript here, so let's console the log it. Console the log factorial of 5. Save. I should see 120. So let me run using node. Control backtick. So drag this down. I'll call it say node examples. So I can see 120. So the factorial of 5 truly is 120. So you can also confirm by doing 5 times 4 times 3 times 2 times 1. So let's try out factorial of 3. Factorial of 3. So this should be 6. Yeah. Factorial of 3 is 6. 3 times 2 times 1, 6. So good. So this is the most basics of recursion examples. Good. Let's kick it up a notch. Example 2. Okay, so now let's do a Fibonacci series, not the actual Fibonacci series, the nth element in the Fibonacci series. So a Fibonacci series is basically saying, or basically means that the next element is the sum of the previous two elements. Okay, so the Fibonacci series mostly starts from 1, but some examples you see starts from 0, or it most likely starts from 1, or most times starts from 1. So the next element would be 1. Why? Because the sum of the previous two elements. The next element here, there's no previous two elements. We only have one element. So the previous elements can just be assumed to be 0. That's why sometimes start with 0. Okay, so we can just say the first actual element is 1, the next element is 1, because 1 plus 1 equals 0. So the next element after 1, which is the third element, would be 2, because the sum of the previous two, 1 and 1, gives you 2. Next element will be 3, because 2 and 1 will give you 3. Next element will be 5, next element will be 8, next element will be 13, and so on and so forth. So you should get that now. So how do we implement this using recursion? So we're not printing out the whole series. We just want to print out the value at a particular position. So if we enter the value 3, so we want to get the third element, which will be 2. If we enter 5, we want to get the fifth element, which should be 5, and so on and so forth. So the seventh should be 13. Okay, so let's say function, let's call it Fibonacci. So here 1n Fibonacci. So n represents the number or which element at what position do we want. Okay, our function. Now starting with our base case again. So this we have two smallest versions, or the lowest of lowest values here would be 1 and 0, because it will get to a point where we need like the 0th element, since the second element refers or needs the previous two, and since 1 is the first element, we need the 0th element, which is going to be 0. So in our if statement here, we'll just say if n is less than or equals to 1. So basically saying if it is 1 or anything below 1, which is obviously going to be 0 alone. So 1 and 0 here. I want it to return n. So in this case, I'm not returning 1. Why? Because n is not only going to be 1. N is either 0 or 1. So whatever n is, return that. Okay. And for the recursive case, I would say return. Now call the function again, Fibonacci of n minus 1 plus Fibonacci of n minus 2. Remember, the value at a particular element is the sum of the previous two, right? So if I want to get the value at position n, I need to know what the value at position n minus 1, that's the value before it, and the value before it, which is n minus 2. Okay, so this implementation is correct. So what it basically does, let's use a simple value like Fibonacci of 3. So let's say fib of 3. So fib of 3 would be, since 3 is not less than or equals to 1, it skips right past that, comes here. So that would be fib of 2, 3 minus 1, 2, plus fib of 1, 3 minus 2, 1. So it executes fib of 2 and fib of 1. So let's do fib of 2 first. Fib of 2. So what's fib of 2? Skips right past this, comes here. So 2 minus 1 will be fib of 1 plus 2 minus 2 gives us fib of 0. So you can continue from here. Remember, fib of 1 gets executed now. So when it's executing fib of 1, Fibonacci of 1, is 1 less than or equals to 1? Yes. So return n, which is 1. So return 1. So that would be 1 plus. Now, fib of 0, it gets stuck here too. So that would be, is 0 less than or equals to 1? True. Return 0. So 1 plus 0 equals 1. So it means the Fibonacci, the second element is 1, which was proved here. So 1, 1. Correct. So that's just for this. So it means that's equals to 1. So we still need to calculate Fibonacci of 1. So we already know that Fibonacci of 1 is 1. The first element, right? We already calculated it here. So we can just say 1 plus 1. It means the third element, Fibonacci of 3, is 2. So the third element is 2, which is this. Okay? So let's confirm that. So log Fibonacci of 3. So save, run it, okay, let's comment out. Okay, let's comment out these two. Comment, save. So run node examples again so I can see it too. So now let's do something fun. Let's get the first 7, or let's get from the third to the 7th. So 3, 4, 5, 6, 7. Let's get the 8th too. So 8, save. So that should be 3, 2, 3, 5, 8, 13, 21. So you can see 2, 3, 5, 8, 13. So 13 plus 8 will give me 21. So now our Fibonacci series implementation works perfectly. Okay. Next example. So I can just snip this. Next example. So example 3 would be sum of all elements from 1 to n. So whatever number you ask or you pass as an argument, it will return the sum of all the elements from 1 to that number using recursion. Okay, so we can call the function sum. Let's call it sum t, sum to n, or sum tn, sum tn. Okay, so pass n as an argument. Obviously you can use any number, so let's use num this time. So num, right? Our base case as usual. So if what's the lowest number? The lowest number there should be 1, right? So you cannot always refer to the highest number. Remember, the base case should always have something to do with the lowest version, which in this case is going to be 1. It's literally starting from 1. So say if num equals 1, return 1, as easy as it comes, right? Return 1. So what we're going to do here is, if I say sum of all numbers from 1 to n, so sum of all numbers from 1 to 3, that's 1, 2, and 3. it's still the same thing as doing sum of all the numbers from 3 to 1, 3 to 1, right? I'll still get the same number. So it's actually easier to come down than to go up. Okay, so let's use that now. So it means our recursive case here, return what? Return the number n plus, so starting from the highest number, let's say 3, the entire 3, so it will be 3 plus sum tn, call the function again, then the num, but this case minus 1. Okay, so the number has to reduce, and again, in every recursive function there should always be some sort of reduction, downgrading, so as you can solve the smaller version. You can't just pass, if I were to pass the same number num, okay, sorry, not n here, if I were to pass the same number, the function will go infinitely. So if I were to pass the same number there, the function will go infinitely, and we do not want that. Okay, so I have to pass minus 1 so that it can keep solving the smaller version. So this works immediately. Let's try out some tn of 3. Let's just say s of 3. Right, so s of 3 would do 3 plus s of 3 minus 1, 2. So what's s of 2? S of 2 would be 2 plus s of 1, and we already know that when we pass 1 as an argument, it's going to be stuck here, so it will return 1. So 2 plus 1 will be 3. So s of 2 is 3, and s of 3, or s of 2 is 3. So that would be 3 plus s of 2, which is 3, which will give me 6. Right? So sum of all the numbers from 1 to 3 is 6. Okay, so the number included, I guess. To save, test this out. So if I were to try something of 3, run node examples, I'll see 6. So I've not commented out these two. Save, let's run it again. Now it's C6. Yep, so that's sum of 10. So let's do something closely related but a little bit harder. So example 4, let's find the sum of all the elements in an array or list using recursion. Okay, so sum of all elements. So since we're using JS in an array, call it an array. So in an array. Okay, so define the function sum, let's call it sum all. Okay, so we're going to get 2 arguments. We'll collect an array, say ARR, and the index. So if it were to be Python, I wouldn't need to take the index because slicing of lists is so much easier in Python. Okay, but since we're using JavaScript, I just want to collect the index, and automatically the value of the index should actually be 0. So let me set it as the default value actually. Okay, so I'll say index equals 0. So the base case, remember the smallest version, right? When the array only contains one single element, when, since in this case we're using index to move, so when the index is at the last position, return the element at that position, right? So say if the index is equals to array dot length minus 1, right? So if the index, so this index would be increasing, as we're increasing the index, we're moving further down the array, right? And the last index is the length of the array minus 1, since it starts from 0. So if an array has 3 elements, the last index would be 2, so the length minus 1. So I'm basically saying if you are the last index, I'll say return the element at that index, so array index. So here we're using index slicing, so this will return the element at that particular index. Okay, now the recursive case, so say return. So just like when we did the sum of 1 to n to a particular number, we say the n plus the number before it, right? Or until we get to 1. So in a similar case, we're going to get the first element in the array plus the next until we get to the last index, right? So I'll say array of 0, then plus, call the function again, sum all, then we'll still pass the same list or the same array, so arr, then what? Then we're going to increase our index. So increasing the index is basically telling us move this value, then we're going to increase our index. Okay, so if I look at that arr of 0, the first element, okay, this will keep using the first element, so we cannot use arr of 0, we use arr of the current index. Okay, so here we used arr of the current index, so whatever the index is on, that's what will be added here. Okay, and when the index is at the last index, return the array at that index. So let's play it out. So let's call it SA. So SA, we're passing 1, 2, and 3, and obviously starts from 0, the default value. Okay, so now what is SA of 1, 2, 3, right? So SA of 1, 2, 3, I'm returning array at the index. The index is 0 initially, so array of 0, which is the first element, so that would be 1. So 1 plus SA of the array again, so 1, 2, 3. So let's just write it out again, 1, 2, 3. So instead of writing 1, 2, 3, let me not repeat myself. Let me just say ARR, right? ARR, then index increases to 1, so 0 plus plus becomes 1. So SA of the same array plus 1, right? So SA ARR of 1, what is that? So the index is at 1 now, which is the second element. So array of the second element, which is 2, so that becomes what? 2 plus SA of the same array, then index becomes what? The index becomes 2, right? So now what is SA of IRR array 2 equals what? Equals 3 plus, oh no, not 3, it gets stuck here because the index 2 is already at the end. Remember the length 1, 2, 3, 3 elements minus 1, 2. So the index is already at position 2. So just return the index there. So that will just be, or the array there, right? So that will just be 3. So SA of the array at position 2 is 3. So it means instead of this, it should be 2 plus 3, giving us 5. So this should be 1 plus 5, giving us 6. So 1 plus 2 plus 3 gives us 6. Okay, so yeah, that will be the implementation. So now let's console.log, let's say sum all of, let's pass 1, 2, 3, and default value 0 as usual. So we shouldn't need to pass that actually. So let me just pass a single argument. Okay, now let's run this. Sorry, node examples. So we can see an error here. I can see maximum call stack exceeded. Okay, at line 52, 50. Okay, at line 57. Okay, at this line. Okay, because of the post increment. So if we were to use per increment, let's say plus plus index, save, run it again. Okay, now I can see 6. So instead of per increment post increment, let's just increase by 1. So let's just say index plus 1. Save, run it again. Good, 6. So let me comment out this sum to n. Okay, so that was our fourth example. The fifth one, so we're done dealing with numbers. Let's look at an operation on strings with recursion, and that would be reversing a string. Reversing a string. So now we need to take a breather and change your implementation, change how you've been thinking of index 1, return 1. Okay, so if you feel like you're comfortable enough, you can pause the video and try this, but or if not, you can follow along. So let's say reverse str. All right, so now our base case. Remember, base case is not only about 1. right? It's always about the smallest version of the problem. And since we've been dealing with numbers, 1 or 0 is the smallest version of the problem, right? But in this case, it is the last or first character. Okay, let's just say last character of a string, right? A string is a sequence of characters. So if we only have one character or even no character, I think yeah, no character should be the smallest version. If you just call the function and pass an empty string, that is the smallest version, right? Good. So I'll say what if str equals double equals an empty string, right? If it's an empty string, return that empty string. So note, it's not always about one. Okay, so recursive case. So now return what? So since I'm reversing, right, and obviously I'm going to be starting from the first element, what I want to do is I want to recurse first before I return the elements at the start. Right, so I'll be using the car as function. So I'll say str, right? Okay, let me make it look like a string. Just default it to a string so it can give me the functions. So str dot character at 0. This is for JavaScript, right? So the character at index 0, I could have used indexes too. So the character at index 0, that's the first character, right? Now before that, plus, so say reverse, right? Reverse. Now the rest of the string. Addition with strings is different from addition with numbers, right? If we're adding characters together, that's basically concatenation, right? You might see it as the same thing, but it is not. Okay, if I say A plus B, I get AB. But if I say B plus A, I'll get BA. If we're using numbers, and I did 2 plus 2, or if I did 2 plus 3, I'll get 5. And if I did 3 plus 2, I'll still get 5. So concatenation, the order matters. Okay. So here I'm saying reverse the rest. So the first character automatically is going to be the last character, right? So the first character is going to be the last character automatically, right? So if I was reversing the string hello, right, I can already say that the last character is going to be H, which is what I'm doing here. Take the first character and just add it to the back. So reverse the others. And just attach the first character to the end. So just keep on doing that until it doesn't have any other character, then get the sequence follows. So what am I going to do here? I'm going to reverse the rest, right? So apart from the first character. So I'm going to slice here. So JavaScript has the function slice. So slice from the second character to the end. So I don't need to do str.length, right? The last character, then -1. So if I just specify one argument, it starts from the second character. So just like indexing 0, 1, starts from the second character and goes all the way to the end. So it's to attach the first character to the end, H, and I'm calling hello, right? So then like that, like that, like that. So let's play it out, let's check it out. So if I were to reverse hello, right, that would be reverse, let's say r of what? R of hello, because I'm taking from the second to the end, plus H, right? Remember, concatenation is different. Whatever comes first is what will be in front. It's not like numbers, right? So now what's the reverse of hello? That would be what's the reverse of LLO. Remember, from the second to the end, plus what? Plus E. So E has been removed. E becomes the new first character, right? So we do it again. R of LLO would be what? R of LLO would be R of LO plus L, right? Almost the same thing. R of LO would be R of O plus L. I can just duplicate this line. Now R of O would be R of empty string plus O, right? Plus O, and R of empty string would be what? So now the if statement catches it, the base case returns an empty string. So now return an empty string. So coming back to R of empty string, so that's basically empty string plus O, which becomes O, right? So R of O is O, so that would be O plus L, which will be OL. Attached, concatenate them together. So R of LO is, since it's R of LO, so R of LO is OL, which will be, so replace that here, OL plus L, which will be what? OLL. So R of LLO is OLL. Come back up. R of LLO is OLL plus E becomes OLLE. And finally, R of ELLO is OLLE plus H, OLLEH. Okay, so to test it, let's say console.log or just log reverse hello. So you see OLLEH, not examples, OLLEH. Okay, so yeah, those are basic 5 examples that implement recursion. So just to test your understanding, you can try this. So a simple exercise. So try finding an element in an array using recursion. Okay, so the function should look something like this. So let's say find, right? So you pass the array. It can also take the index, or let the index be there. Let's say targets. So array targets and the index. Okay, so the function should look something like this. Yeah, and that's the end of the video. You can drop your answers in the comment section. I'll look at that. And that's basically it. So I didn't also master recursion at first. Recursion is a very tricky topic, and you can't just automatically assume the base case, assume the recursive case. You have to actually model it out, scale it out, probably on a piece of paper. So yeah, practice makes perfect. So make sure you practice it, model it out, and you understand the concept of recursion better. Okay, so make sure you like, share, and subscribe to your friends who you think should learn recursion.